Hello, and today we're going to construct a perpendicular from a point to a line. Sometimes it's just called the perpendicular, uh, but a perpendicular from a point, so our point X is in this case, to a line passes through the point and meets the line at a right angle. So that means our first thing that we're going to deal with is our X. So is our point. So our trait here is the perpendicular from a point to the line is the shortest path or distance. So this would be what your phones or location sometimes say if you're going on a flight and it says, okay, from the UK to Canada, specifically from, let's go from London to Calgary, and we could say, I'm just going to guess, maybe it's 2,000 miles, right? We call it as the bird flies. That is our shortest distance. So lots of times maps will do these things, but realistically, if we're going to walk somewhere, we know that we're not typically walking the shortest path, but that's what a perpendicular will do. So here is our example. So we want to construct, using a ruler and compass, the perpendicular to x to the line AB. Okay, so that means our point here is x. So we want to, first off, place our compass on our page and extend it a little bit. Okay, my line's there, so I'm going to extend it, well, probably somewhere like there, and we'll just see what happens, right? If we find that we don't actually get any marks on our page, we know we have to extend it more. So the rule of thumb I typically go with, is grab our compass, stick it on our page, and kind of, well, it's going to hit our line if we start extending our arc down, if we start drawing. So we just need it to hit in two different spots. Okay, so we've extended enough out, and now I'm going to put it on our mark. So our pivot point is on our mark as best as possible. I'm going to switch to red so you can see it a lot easier. So we are going to draw an arc that passes the line. So here, we've crossed at one point, so let's just keep going around. Now we've crossed the other point, so we can stop. That's step one. Step two, we want to place the compass point on one of the intersection points. So we have two intersection points, right? We have here, and we have our other one over here, correct? So we have two intersection points. So we want to place it on the intersection and draw an arc on the opposite side of the line in comparison to the point. So wait, what? What does that mean? Well, all it means is such. Let's grab our compass. Okay. And bring it down. Put it on our intersection point. Let's draw it on the opposite side of our line. So I've drawn mostly a circle right now, but we're on the opposite side of X. So here, place it on, and this time I'm just going to go what I require. So just where these points meet up, just right there. So notice, now we have this intersection point here. It's our bottommost one. Okay. Trying to point best to it with a few arrows. So this intersection point, and we have another point, our original point, X. So like usual, anytime we have 2 points, and we're trying to find a line, we just take it and we connect our 2 points using a line. So use your straight edge ruler and we connect them as such. Okay, you can go back and check and use a protractor, but at X we have a perpendicular line. So I'm just going to scroll down, leave that there, so you have a little bit of step-by-step procedures if you'd like to copy them. Okay, so now that we've gone through one example, let's try out another one. So use a compass and ruler, construct perpendicular line at point Y. Well, first off, one thing I'm just going to do, just provide a little bit better clarity. I'm just moving mine down. When you're doing this at home, you are just drawing yourself a line, making yourself a point, and trying this out, right? The only way to truly know is just to try, and then you go back and check your answer with a protractor, right? Keep in mind, they'll always give you a little bit of variance or a little bit of, okay, well, you're not completely accurate, but you're pretty close. So here, put it on our point Y, right? And draw it around, connecting, hitting it at two different spots. One thing I didn't mention really in the last problem, but it's something that we do for most of constructions. So once you've set your compass at the beginning, do not ever move it. That's typically standard with most constructions. So here, we draw a line up. It's on the other side of Y. Then I'm going to switch. We can switch the compass around and put it on our other intersection point and the line segment right here. And then we're going to do the same thing. Draw over, take it away, grab our straight edge, and from our Y point, connect where those two intersection points met. Okay? So, just kind of show you that, hey, it doesn't matter once again if we have this in a weird situated orientation. This one's on an angle, but we can check and we can still check that it still meet at 90 degrees. Okay, so here is some practice for you. So I want you to go ahead and try these out. They're a little bit more worded problems, as constructions usually are. So draw a triangle with vertices labeled ABC and construct the perpendicular to point C to the line AB. Okay. Then draw 3 nonlinear points on your page. Choose 2 points and draw a line. So that just means 3 points, such as, they're just not in a straight line. You cannot have, this is a no, this is a yes. Okay? This one, you're just drawing yourself a triangle using a straight edge and label it ABC, like I said. And lastly, draw a triangle using a ruler. Construct a perpendicular from each of the triangle's corners to the line opposite that corner. So I'll give you your hint that you are going to have, well, if you're doing it from each corner, that means you're doing 3 constructions. Okay? So if you're doing 3 constructions, it's a kind of a bigger task. But if you understand this, well, one thing you can do is just not move the compass, and you can, you'll find out your own little tricks. We'll go through them together after. Pause the video now, and we'll take this up. Right. So, draw a triangle with vertices labeled A, B, and C. Okay, so I'm going to do just that. I'm going to go ahead and just use the shapes that I have already. So, draw a triangle. And, well, it says at point C. So we only have to do at point C. I'm actually going to be a little sneaky, and I'm not going to label till after. Because what that allows me to do is I get to pick and choose what point I want to do it on. Afterwards, I can just label that point C. So I'm just going to use this point. So construct the perpendicular to point C to the line AB. So here we have our point. I know that my line AB is going to be this. So I have to touch. Oh, didn't touch because it's not extended past. So make sure it's going to be a bit hard to find that proper point. So there. I don't really like that. So this is where it's going to be a little finicky, and it probably would have been better for me to draw a triangle a little bit bigger. But you can see now we have it touch in 2 different spots. Okay, so what do? Take our compass over here, and now we're going to draw our one arc. And then over here, we draw our second arc. Okay. Now, we draw through our intersection point. And apart from mine just being off a little bit at the origin, just do the fact that I should have did my drawing a little bit bigger. Is that. So, lastly, like I said, I took a little shortcut, so I have to go back and backtrack. So, C, and then we know A, B. Okay? So it doesn't matter, we could have labeled B, A, and A, B. We just mattered that that was C. Okay. So, next one, we want to draw 3 nonlinear points. So let's just go doot, doot, and doot. Now it doesn't matter which 2 I'm going to connect, but for ease, I'm just going to connect my bottom 2 points. It doesn't really matter if they're connected properly too much, because we're just going to use the points. So we want to draw a line and then find the perpendicular. Well, it seemed like it was a really hard problem at the beginning because we didn't have a drawing, we didn't know what we're doing, but we've set this up now to something that we know how to do. So at this point, we can switch. We can grab our compass, put it on our page, right, and we're going to draw our 2 lines, or our 1 arc, I mean, with our 2 intersections. Then we draw put it over here, and we draw our 1 arc there. We can put it on our other point, and then draw our other arc. Lastly, we have to actually make our intersection line. So we can create our perpendicular. So our perpendicular there is in black once again. And lastly, this is kind of the harder problem. So if you were just quite understanding the beginning process and you wanted, now that you've done it, you wanted to pause it again, I'd advise it because we're just going to recreate lots of problem 1. Okay? So this time I'm going to give myself a lot more space and I'm going to draw quite a bigger triangle. That's going to allow me to make these construction points. So keep in mind that we're going to do this a lot of times and we're not going to move the separation distance as best we can. Or I'm not going to. So just trying to see how I want to set mine own up. So I apologize. Okay. So that looks good to me. So I'm going to draw it there. Oh, I went a little bit out of the ballpark. So let's take that back. And let's go in a bit. So it's going to work. It's not the best, but it'll work. Okay. And I am just actually going to go and do all of these points right now. Just because I think it'll make my life easier after. I can also check that they all actually work. And I changed my compass distance. So there's that one. So you can remember it's at 220 just in case it changes. So here, oh, it's not actually going to hit. Is it? Oh, barely hit that one, right? So it still did, which is fine, and we can do our very last point, which is that corner down here. Doing our corner down here. Once again, that's not the greatest because it just barely goes over our line, but we're still going to use it because we're still going to get out of our question, I think, what we want, which is just creating 3 different perpendiculars. Okay. So at this point, now start to draw in your lines if you haven't already. So here, I know that I'm going to do these actually in different colors so we can see better. So we have one, right? We're going to switch it around, put it on our other point, and draw our other arc. And we're going to continue and repeat this procedure for every single one of our points where it crosses our line segment and one of our arcs. Okay. So just takes your time. And you can tell it. This is why I think some people don't like constructions that much, because it can begin to look rather messy for the complicated problems. But it all seems to always come together. I promise you that. Problems like this question, if you're not 100% sure, can be hard. So, I've drawn my 3 different cases. Now, what am I going to do? Well, I'm drawing my perpendicular lines now, right? So, you just take it from your point and over. And we're going to do this. We've done it for the first 2. We've got the last one, which is a little bit farther down. So, there. So, what have we done? Well, my points are just a touch off, and I am going to be honest, this is, I think, largely just to the fact of working on a computer. Constructions are relatively easier through use of paper. That's why I urge you to practice these a lot on paper. But what does this do? Well, this is the intersection of where the angles meet, right? So we were commenting. We have found 3 different perpendicular lines, right? So we have found, well, this is 90 degrees, and we're going to find where these 3 meet. So we're splitting these triangles up. So we have split these up into matching triangles. So this triangle shaded in red matches this triangle. This triangle shaded in green will match this triangle. And this triangle shaded in blue should match this triangle. So when they have things where to comment on the result, you just have to find something to comment on. There are many things typically to comment on. We could talk about many different things, but I just left it open just to comment on the result, just to get you to start thinking. So I'm just bringing in the fact that you've created now a whole bunch of pairs of equal triangles. One last thing you can mention about these intersection lines is that they meet at a single point